see how to plot this graph now. First thing, write the date, write the title, a graph of what? A graph of log D against log I. Okay? Then you notice something from your graph table. The table have negative and you have negative and positive. So for the vertical, everything we are negative. I can say, okay, since I have two positive in the horizontal, that is log I can come here and put my what? 0. That means here is my what? Cartesian axis located. Where is located? And is also located here and what? Here. So I will say here is minus 0.05 minus 1. Minus 0.10 minus 0.15 0.20 minus 0.25 minus 0.30 minus 0.35 minus 0.40, and we are to get up to 5 minus 0.45 minus 0.50. Then for horizontal, this is positive, and this is negative. This is your log what? D. While this is your log what? I. No units. So here is negative. Minus 0.05 minus 0.10 minus 0.15 minus 0.20. Are you getting it? We'll come here, minus 0.05 minus 0.10 minus 0.15. We are plotting minus 0.52 against minus 1.5. Okay, this is positive, please. So this is positive y-axis against minus 0.52 against plus 1.5. We locate it here. Minus 0.4 against 0.4, 0.04, 0.04, minus 40, so about here. Then minus 0.3 against minus 0.05. We take here. Minus 0.22 against minus 0.15. Then minus 0.15 against 0.2 minus 0.22. Okay, so we have located our points. Let's get our line of best fit. Wow, so this is the line of best fit of this graph. Okay, now we take our slope. Then now you say here is a change in log D equals to, look at how to take your slope. The highest part is called your D2, that is log D2. The lowest part of it is called D1. Then where the vertical and horizontal meet, you will call it I2. Then this other one will be I1. Look at what we mean. We will say that here is minus 0.15. Minus 0.15. Then minus, you move down, trace this one, minus 0.45. So when you check up this, you'll be having 0.3. You will be having 0.3. You say slope equals to change in log D or over change in log I equals to log D minus 0.15 plus minus times minus plus 0.45 all over, then I2 change in I log I2 will be giving you, here is minus 0.2 minus, here should be about 0.07. And so this will be giving you 0.30 all over minus 0.27. Use your calculator. 0.3 divided by minus 0.27. That will be giving you minus 1.11. It will not have unit because of this log that is already there. You have it this way. And so this is your slope. They said we should get the standard error in the slope. To get the standard error in the slope, there is need for you to what? Get the centroid of each of these what? Data. Add up this, divide it by 5. You'll be getting minus 0.318. That is minus this, minus this, minus this, minus this, minus this. Divided by 5 to give you this. Here, this plus this, then minus this, minus this, minus this, divided by 5, it will give you this. And so, here, if I approximate this, you get minus 0.05. Then, if I approximate this minus 0.3, you get it here. That means here is where your centroid is. Ordinarily, it is a must that you locate your centroid before you get your line of best fit. But because we have been running graph before now, we have run so many graphs, so we are no longer a learner. So that is just why we didn't consider it. But it's best you plot or locate the centroid, circle it before you put your line of best fit. Now, after putting the line of best fit, I have to take this one that fall out. I have to take this point that fall out and locate it to the line of best fit so that it will pass through it. That will be my worst line of best fit. So as I have done that, watch it. That means I am starting from here to check my what? Slope. Stop here. Then stop here. So what is my D2? My D2 is about minus 0.21. What slope equals to minus 0.21. because this is minus 0.2, so minus 0.21 before this. Then this one will be what? This one will be minus 0. So once I write minus 0.21, this point, then I will say minus bracket minus 0.45 all over, look at that 0.45, look at it, all over, what is this one? Here is minus 0.2 minus, then what is here? Here is about, this is 0.1, so 0.1, 0.15, so here will be about 0.12, 0.12. Yes, since here is 0.1. Then we locate it in our calculator, we check it out. We say minus 0.21 plus, minus times minus is plus 0.45. That will be giving us, divided by bracket minus 0.2 minus 0.12. That will be giving us minus 0.75. So this is slope of the worst fit, line of worst fit. Why this is for the best fit? Error of this slope, error in this slope will be equals to modulus of you subtracting the two minus 1.11 minus, so minus 1 plus 0.75. So minus 1.11 minus this will give you plus. So you have minus 1.11 plus 0.75. That will be giving you 0.36. That is minus 0.36, but this modulus will take care of the minus 0.36. That means that our error in this slope is this. You package your slope as slope equals to minus 1.11 plus or minus 0.36. So this is your slope. This is your slope. Now we have gotten our slope. To get our intercept, we say intercept simply means where it cut the y-axis. So the line of best fit, look at this line. It cut the y-axis at minus 0.36. You say minus 0.36. That is our intercept. We have gotten our I, which is the intercept. The intercept of the best fit to be equals to minus 0.36. Yes. Now they say also find its standard error. To get the standard error, I will use the principle of worst fit and what best fit to get it. This is the best fit on, and this is the worst fit what on. So the worst fit, cut the y-axis at what, or the vertical axis at this. You just read off the value. Reading it off, I would say I of the worst fit is equal to, here is minus 0.35, here will be minus what? 0.34. Use your graph, your standard graph, and get the exact value. Okay? Now the error will now be equals to you getting the modulus of it. You will be having minus 0.36 minus bracket minus 0.34. Are you getting it? And so modulus mean neglect negative if you get negative answer. So 0.02 will be the answer. That is the error in the intercept. We have gotten the slope, error in slope, intercept, and error in the intercept. Next on our list is if D and I are related by D equals to K I raised power n, where K and N are constant. Use the result to find values for K and N. Include the standard error in your values. But before we go to the question number C, remember the title of the experiment says determination of resistivity of a wire. Experiment on determination of resistivity of a wire. Now, why or how can we get the resistivity of this wire we talk about? Now, for us to get the resistivity of the wire, it means that we are going to plot the graph of D against inverse of I. Plot the graph of D against inverse of I. Are you getting it? So, inverse of 1.4 is 0.71. Inverse of 1.1 with 0.91. Inverse of 0.9, 1.11. Inverse of 0.7, 1.43. Inverse of 0.6, 1.67. You note it. How do we know that you have to plot the graph of D against inverse of I so as to get the resistivity? We noted it this way. We say resistivity is equals to RA over L, where this L in this experiment represents the distance. This distance is not what? The diameter, you know, just the distance, the length, so to speak. Let us use the length before you get confused. Then we also note that voltage is equals to current times resistor. That means current is voltage over resistor. Resistor is equals to what? Or resistance is equals to what? Voltage over current, right? We say that R is equals to V over I. The effective resistance equals to voltage over what? Current. Therefore, this becomes VA all over what? IL. Then we make L subject of formula. We have that L is equals to VA all over resistivity times what? I. This can be packaged this way. L equal to VA over resistivity times inverse of what? Current. Times inverse of what? Current. Can you see it? That means whenever you plot the graph of L against inverse of current, the slope becomes VA over resistivity. The graph of L against inverse of current, the slope will become VA over what? Resistivity. That is why we say plot the graph of D, which is your L, against inverse of current, and when you do it, your slope you will get will be equated to this. Then you make your resistivity subject of formula. That means, dear students, please use your graph and plot graph of D against I inverse. When you use your graph to plot it, tell me what you get as a slope. Yes, I want to see your slope. Use the comment box and tell me your slope. Now, since I couldn't make it to plot the graph, let me use tabular method and check what will be the range of the slope. The range of the slope will be equal to change in D all over change in I inverse. Change in D all over change in I inverse equals to this minus this 0.7 minus 0.3 all over 1.67 minus 0.71. 0.7 minus 0.3 all over 1.67 minus 0.71. I will use my calculator. 0.7 minus 0.3 divided by bracket 1.67 minus 0.7. That will be giving you 0.41. 0.41. Are you getting it? .42. Approximately, it will give you 0.42, please. 0.42. Now watch this. This is a meter and this is A inverse. Meter over A inverse. Now that means that the unit will be 0.42 meter what? Ampere. Meter ampere. We have noted this. That means if you plot your graph, your slope will be around 0.39404142. 0.39, 0.40, 0.41, 0.42, 0.43. It will be around that range. Meter ampere. Remember the slope and the units, it matters so much. Now, after you have noted this, how can you now deduce your resistivity from this slope of you, or from this slope you got from D against I inverse? Oh yeah, let's see how you can deduce your resistivity from it. Remember, I say equate it to what? Equate your slope, graph of this against this, right? That means whatever you get will be your what? Slope. Okay, equate your VA over resistivity to what? 0.42. If you get 0.41, stay in order. 0.40, stay in order. Are you getting it? Now watch it. We noted our A to be pi r square or pi d square over 4. That is the area of the constatant wire. Are you getting it? And when you do this, when we computed it, we got 0.07 times 10 raised to power minus 8 meters squared. We did it in the starting part of this video. Then the voltage was given to be 3 volts. Then make your resistivity subject of formula. Resistivity will now be equals to 3. Resistivity will come up, 0.42 will come down. 3 times 7.07 times 10 raised to power minus 8 all over 0.42. Now watch it. 3 times 7.07 times 10 raised to power of minus 8 divided by 0.42. That will be giving you about 5.0 what? 5 or 5.1. That will be giving you 5.1 times 10 raised to power of minus what? 7. Minus 7 ohm meter. The unit of resistivity is ohm meter. Okay? So be able to note all this we just solved. Be able to note it. That is, if you want to get the actual resistivity of that wire, you have to plot the graph of what? D, or which we call L, against inverse of the current you got. Whatever you get, equate it to what? VA over what? Resistivity, and make resistivity subject of formula. But in this video, we were not asked to plot the graph of D against I inverse. We are just asked to plot the graph of log D against log I. And so we have to obey the simple instruction, okay? So that is just for it. We now go to question number C. Okay, we now go to question number C. If D and I are rated by D equal to K I raised power N, where K and N are constant, use the results to find values for K and N. Include the standard error in your values. Now see what you do. You write the formula given to you. Now you have to convert this formula to linear equation. You have to convert it to linear equation. Are you getting it? You have to convert it in a way you understand it. And to do that, take log of both sides. Log d equals to log bracket k I raised power of n. Now applying law of logarithm here, that multiplication or addition law, we say log d equals to log k plus n log what? I. That means when you plot the graph of log d against log I, n will be your slope. Therefore, my n will be equal to, what is my slope? Minus 1.11. No unit. We got this this slope in the starting part of the video. When we check slope of the line of best fit. When we check the slope of the line of best fit, we got minus 1.11. In case you have forgotten. Then, now we have gotten our n. The error in the slope, the error in n, the error in n. Since we have gotten our n to be minus 1.11, the error in n becomes the error in the slope. It becomes the error in the slope. And what is the error in the slope? We got it to be 0.316. That is, we have done it before now because n is the slope. Then, if n becomes the slope, log k will be the intercept on the vertical axis. Therefore, we say log k is equal to the intercept. And we got our intercept to be, intercept of the best fit to be minus 0.36. That means log k means log k to base 10 equal to minus 0.36. We will tell them that k is equal to 10 raised to the power of minus 0.36. So we say 10 raised to the power of minus 0.36. That will be giving you 0.44 equals to 0.44. No unit for it, because log of anything has no unit. Then we still come again. They say include the standard error in your value. Standard error in k is a constant. K is a constant, and since it is a constant, now since k is a constant, if you want to get the error in this k, we can say error in k equals to the k times error in the intercept. The value of k times error in intercept. Okay? And so when we have it this way, we'll be having it that error in intercept is 0.02, and therefore error in k is equals to 0.44, which is the actual value of k we got, times the error in the intercept, 0.02. Yes. When we do that, 0.44 times 0.02, that will be giving us 0.008. Therefore, our k is equals to, approximately 0.009. Okay. Our k is equals to 0.44 plus or minus 0.009. No unit. Are you getting it? That is just it. Then We have gotten our n and the what? Error in n. That one is self-explained. We have gotten our n and the error in n. Okay? That is by the way. Now, question number 4. Question number 4 says, a certain wire has resistivity 2.5 times 10 raised power minus 6 ohmmeter and diameter of 1 millimeter. Calculate the length of the wire needed to make a resistor with resistance 1.0. So this is the continuation of question number D. So if they ask you to get this, remember that resistivity is equal to RA all over L. That is your resistivity. And they say you should get your what? L. Your L will be equals to RA all over resistivity. Then what is your A? A is pi R squared equals to 3.142 times what is your R? Diameter over 2 is R. So 1 over 2 will give you 0.5. You say 0.5 times 10 raised power minus 3. This is in millimeter. Convert it to meter by multiplying by 10 raised power minus 3. Then you square it. Are you getting it? So you have 3.142 times bracket 0.5 times 10 raised to the power of minus 3 squared. That will be giving us 7.86 times 10 raised to the power of minus 7. We have gotten our A. Then our R was given to be 1 ohm and our resistivity was given to be 2.5 times 10 raised to the power minus 6. So getting our L, we say that our L is equals to, what is your R? 1 times what is your A? 7.8. Let's write it well, please. L equals to 1 times 7.86 times 10 raised to the power of minus 7 all over our resistivity is 2.5 times 10 raised to the power minus 6. You use your calculator. A6 times 10 raised to the power of minus 7 divided by bracket 2.5 times 10 raised to the power of minus 6. So that will be giving you that L is equal to 0.314 meters. Okay? And so that is how to compute this experiment. That is how to sort it out. I've told you guys that if you want to get your resistivity of that material, so to speak, plot the graph of D against I inverse. When you do that, get the slope. The slope equate it to what? VA all over what? Resistivity. When you equate it, make resistivity subject to formula. It will give you the resistivity of that what? Wire. Then we have seen how to get the slope, error in slope, the intercept, and error in intercept using the principle of worst fit and best fit. If you want to see more formulas on how to get your intercept, type Chidon's Daniel Introduction to Physics Practical. Chidon's Daniel Introduction to Physics Practical. You will see other ways you can use to do what? To compute your intercepts. Okay? So as you enjoy this video, please don't forget to click subscribe, like, comment, and share to your friends. See you in the next practical.